All right, everyone. Today we're going to learn how to install and configure Ret Sync for IDA Pro and connect it with WinDbg for synchronized reverse engineering. Most of the tutorials I've seen on the internet are mostly about Ghidra and stuff like that. We're going to go on IDA Pro. It's supposed to be pretty easy, not something that's so complex. It's already installed on my computer. In short, we're going to need two files called .sync, both in the user directory and in the IDA Pro directory. The main difference between the two is that they both have the same host and the same port. The one that related to the WinDbg as an alliance that we'll be able to add in the future, which help us to fix some naming error. For example, when we're debugging the kernel, sometimes there are mismatches in module names. One kernel build might use one name, while another build, that we downloaded, uses a slightly different one. So it's just an addition that we add to WinDbg's part. Like here. Okay, so basically the easiest thing to do is to download the Ret Sync from the GitHub repository and download the zip file. The first step is to navigate into the Ret Sync directory, open the IDA folder, and copy the required files. Then, head over to your IDA Pro installation path and place them inside the plugins directory. In my case, everything is already set up. As you can see here, the files are already in place because I've previously downloaded them. Essentially, this folder contains the Ret Sync configuration files for IDA Pro, and once that's done, the configuration for IDA is complete. From here, the rest is straightforward. Now let's verify that everything is working correctly. We'll open IDA Pro and, in this example, load NTDLL, although you can choose any module you like. Click OK and allow IDA Pro to fully analyze the code. Let's give it a moment to finish. Once the analysis is complete, navigate to Edit, Plugins, and you'll see that Ret Sync is now available and ready to use. Just make sure that the Hexraise checkbox is enabled, and you should see confirmation at the bottom that the plugin is active and ready. Perfect. Everything looks good so far. Let's tidy up the interface a bit. First, choose any random module in IDA Pro and press F5 to switch into the pseudocode view. Then, enable the Synchronize option, and that completes the IDA Pro configuration. Now, let's move on to the WinDbg side. Inside the Ret Sync project folder, simply double-click the solution file and open it with Visual Studio. All you need to do here is build the project in release mode. Once the build is complete, take the generated sync file and copy it into the WDK directory. You'll also need to copy it into the Windows Apps directory. In my case, those files are already in place, but if this is your first time, make sure to paste them both, and that's it. The WinDbg setup is ready. Now that everything is set up, let's open WinDbg and either attach to or launch a process. In my case, I created a small executable that simply calls the MessageBox API. We'll compile it and then launch it under WinDbg. Once attached, you'll notice that execution breaks inside NTDLL, which indicates that the debugger has successfully paused the process. At this point, we need to load the Ret Sync DLL into WinDbg. Before that, let me quickly show you the contents of the sync configuration file. Both config files contain my local IP address and the same port number. The port is taken directly from the GitHub repository defaults. I kept the default configuration. Everything happening in the debugger is reflected inside IDA and vice versa. And here we can see that Ret Sync has correctly highlighted the corresponding position from WinDbg inside IDA Pro. Great. Now, in order to catch the MessageBox API with both WinDbg and IDA, we need to open a new instance of IDA and load the corresponding DLL. In this case, the MessageBox API resides in user 32 DLL, so let's open that and give it a moment to finish analyzing. Once that's done, we'll run the Ret Sync plugin just like we did earlier with NTDLL and set up the interface. After the setup is complete, we can simply set a breakpoint on MessageBox using the BP command, press G, and you'll see that IDA Pro immediately catches the event. From this point, we're able to reverse engineer and debug simultaneously. In the next video, we'll take this one step further and explore how to do the same workflow in kernel debugging.